Today I'm going to talk about understanding deep learning requires rethinking generalization. This paper won one of the best paper awards at iClear 2017. At that time, deep neural networks, including convolutional neural networks, reached state-of-the-art in many different tasks. And the authors thought that people talked about the performance a lot, but didn't talk too much about the generalization. So they wrote this paper and did several experiments to analyze their generalization properties. They started with this paper with experiments in fitting random labels and random pixels. They found that neural networks are able to easily fit random labels and random pixels. Later, they talked about the abilities of explicit and implicit regularization. They attempted to train with different regularizations, including dropouts, and they found that the generalization performance does not change too much. So this leads to a question about the functions of regularization towards controlling generalization error. Then the authors talked about the finite sample expressivity. They proved that with 2 layers neural networks with ReLU activation and 2n plus d weights, the networks are able to represent any size and dataset with d dimensions. So if you have a wide enough network with 2 layers, you can fit basically all the data sets that are not large enough. Then the authors talked about implicit regularization. So if you have n data pairs xi and yi, you can write x in n by d and y and n by 1 vector, and you want to optimize for a weight matrix w with d plus d by 1 dimensions. SGD will lead to a unique solution. Weight equals x transpose alpha, where alpha is a parameter. When you sub in these equations, you can basically solve for alpha in equation number 3. So the SGD training scheme with L2 regularizations leads to the unique solution very easily. So they verify this by solving the equation 3 and having really high testing accuracies on the minutes dataset. However, this minimum L2 norm intuition does not contribute too much towards the rethinking generalization, because a lot of other things happen during the training process, and the SGD tend to have this intuition does not contribute too much to our understanding of generalization, but it's good to include in the discussion. So now it's 2020. This paper was written almost 4 years ago. When looking back at this paper, people have been thinking a lot more in terms of neural networks generalization ability. Neural networks are able to fit random labels, so it's natural to question what actually they are relying on. Are they relying on the pixels? Are they relying on the relations between neighboring pixels, or are they relying on the real objects that should be extracted from those pixels, similar to humans do? So understanding the mechanisms of neural networks are, I think these are very important questions nowadays.